Hello class, good day. Welcome sa ato ang new topic on basic subsurface flow. So sa hydrology no usa ni sa ko ang pinakaganahan nga kuan topic because here we will be dealing with kuan naman problem solving. So let's start with our discussion. Let's define some terms here. So natin mga additional nga mga terminology here. We have the energy grade line. Its acronym is EGL, and the hydraulic grade line, or HGL. So the energy grade line is a line representing the elevation of energy head in feet or in meters of water flowing in pipe, conduit, or a channel. So ang nasa hydraulic grade line is ang potential, flow, and the kinetic energy of a fluid nga nag-flow within a pipe, a conduit, or a channel. Ang hydraulic grade line, then, on the other hand, is the surface or profile of water flowing in an open channel or pipe flowing partially full. So, in a pipe flowing full siya, na siya equivalent hydraulic grade line sa as if nag-flow siya sa open channel. So, ang nasa energy grade line, we have the potential, flow, and the kinetic energy. So, another nga kuha ng flow energy is the pressure sa water, no? On the hydraulic grade line, we have the potential energy and the flow energy. Okay, so, but since also we are dealing with subsurface flow, so these are flow sa ubos sa surface. So, mo na siyang flow of water sa aquifer. So we know that aquifer are water-bearing structure or kaning structure below the earth nga na ay water. So these are aquifers. So we have the confined aquifer and also the unconfined aquifer. But first, let's talk about this hydraulic and energy grade line sa pipes, and then let's relate it to aquifers. So yes. So di ba we know that ang water flow gyud na siya. So we have a sample here. We have a reservoir, or let's say we call this our supply. So we know that a water flow from a higher point to the lower point. So let's say walay other nga kuan niya ga-influence niya, walay pipe, walay turbine, only the gravity. We know that the water flow within from here will flow from here to here, from this point to this point. Okay? So in soil pud gyapon, ang water flows also. So mo to siya, later i-discuss na to. So here we have a reservoir, and then we have a pipe here. So let's say we have 2 points here. So di ba earlier we discussed about the energy grade line. We have, let's say we call here the point 1, and then we have here the point 2. So unsa may nasa point 1 ug ni point 2. So by law of conservation of mass, we know that the energy at the point 1 should be equal to energy at point 2. So in perfect and ideal condition, and there is no energy loss, so energy 1 and energy 2 is equal. So again, ang energy at 1 natoy ato ang flow energy 1 plus we have the potential energy 1 plus the kinetic energy 1 should be equal to the flow energy at the second one plus the potential energy at 2 and then the kinetic energy at 2. So unsa may na under sa flow energy? So we have the pressure 1 plus the potential energy. So ang formula sa potential energy, if you remember, we have the rho g and rho g h1. And then plus the kinetic energy, di ba ang formula, we have the 1/2 mv squared. But since this is in pressure man siya nga unit, so ang relationship ni mass ug ni pressure, we have the density, so we use the density here. So rho v1 squared should be equal to the pressure at 2 plus rho gh2 squared, gh sub 2 plus the kinetic energy 1/2 rho v sub 2 squared. So ato lang ni ikuan no. So ang row here is the fluid's density. And then ang G is the gravitational acceleration. So kani siya nga equation, this is the Bernoulli equation. Okay, naana po si Bernoulli here. The Bernoulli equation. Okay, so by law of conservation of mass, energy 1 is equal to energy 2. And then, this is, usa lang ni siya ka pipe, no? Usa lang siya ka klase sa pipe. So, mo nito ang assumption. So, energy 1 is equal to energy 2. Since this is in pressure man siya nga kwan in kilopascal, ato ang gusto kwaon is that ang iyang unit is only in meters. We call that the head. So, ang other na to nga pagka-transform na ni is that the energy head at 1, so it's either in foot or in meters, should be equal in as energy should be equal to the energy head at the point 2 in foot or meters. So for the pressure, so atong buhaton na ni is i-divide na to ang whole equation with 1 over the what? The unit weight of the fluid. So again, ang gamma is, if you remember, no, that is the unit weight of the fluid in hydraulics. So para head ang ato ang makuha para in meters na sila tanan. So our P1, pressure 1 over gamma plus, kani here we have the rho G H1 over gamma plus 1/2. So 1/2 rho V1 squared over gamma is equal to P2 over gamma plus rho G H2 over gamma plus 1/2 rho V sub 2 squared gamma. So ang kaning gamma, so unsa may relationship ni, so actually si unit weight ug si density na sila relationship, di ba? If you remember, ang unit weight is just equal to rho times the density times the gravitational acceleration. So kung mao din ni si gamma, makancel ni nato. And then si rho g man si gamma, so equal man din siya ni rho g here. Sa to makancel nato si rho, and then mapabilin si g. So ang final natong equation for Bernoulli's equation, energy head, we have the pressure 1 over the unit weight of the fluid plus the H1 plus 1/2 V1 squared over G is equal to P2 over unit weight gamma plus H2 plus 1/2 V sub 2 squared over G. Okay. So ato ni panganlan no, tagsa-tagsa. This one, we call it the pressure head. Kani siya, we call this the potential energy head. And then kaning last one, we call this the velocity head. So all of these are measured in foot or in meters. Same ra gyapon here, this is the pressure head, the potential energy head, and then the velocity head. So asa man ni si H1 ug si H2? Let's say this is our datum line. So this is from here to there, here this is the H1, and then from here to here, this is our H2. So kaning datum line nato, pwede nato mo bag-bago no, pwede atong datum line is from here or on this side. So let's say if this point ato ang datum line, so ato ang H2 is 0 kay diri naman, and then ato ang measure lang din nga height is from here to here. So equal na ni sila kay mahimo ra gyapon ng H1 minus H2, which is this one. Okay, so this is the H1 and then the H2. Other times ang kaning H is ilang ginagamit nga symbol is Z, like Z1, and then here this is Z2. Okay, so unsa man ning ano naman tay pressure head, unsa pa ni the potential energy head, and then the velocity head. Okay, let's say at point 1, we have a piezometer. So a piezometer, is a, so mano siya ang yang ko ano, is an instrument used to measure ang pressure head of the water. So kung kani siya naiga-flow dira nga tubig, imo nang bangagan dira, di ba kung kanang nai-hose, pag imo nang bangagan manggawas man ang tubig ana. So let's say we have a pipe and then imo nang bangagan dira and then mubutang ka og piezometer. Naay mo sakan ang tubig di ba at certain height. Let's say here at this height. So kani siya, ang piezometer measures the pressure head or the potential. So ang potential is gikan man ipaingon diri, and then we have the pressure head here. So kung piezometer siya, so from this point to sa patasan gamay, let's say this is, we have a head here. So itong pressure here, then diri na po tayo makuha nga certain height. So this is to the center. So this is our P1 over gamma. So that is in meters. And here that is our P2 over gamma. If we use a P2 tube gani, so here sa P2 tube, na ay marid na to ang pressure head plus the velocity head. So mura na siya naka-curve gani. Pag natay tube diya, mura na siya naka-curve. So mo na siya ang P2 tube. So may tabo din ani is mura na siya mo increase gamay ang tubig, di ba? Because kay mura siya og tuklorons, kay di ba mura magmutuklod ang tubig diri pasaka. So naanay pressure diri nga reading plus the velocity nga head nga reading. So if you create a line here from the first point, so let's see kung ato na i-connect. So kani siya diri, kaning additional nga reading here, mo ni siya ang V1 squared over 2G, which is this one. And then kani siya kaning additional po diri nga line, this is V sub 2 squared over 2G. Kani siya, this one. So kaning line here connecting the kuan katong sa piezometer, this is the hydraulic grade line, HGL. But if included na si velocity head, di ba sa atong giingon, kani siya nga line here shows here the energy grade line. So all throughout constant sa pag naa kay P2 tube dira, ang reading then gid nimo dira is ang water is around this point. Okay? So unsa man ni nganong naamay, unsa man ni siya nga part diri nganong, what is this part? Nganong naman tay kulang diri, di ba dapat sa energy from here to here dapat equal sila. So for ideal, equal gid kaayo sila, but in reality naay energy loss nga mahitabo. But energy cannot be created nor be destroyed, so equal gyapon ang atong equation, pero nate added nga ginatawag nato na siya here as head loss. So this is energy loss due to friction. So natay mga major losses, di ba, in hydraulics na discuss man ni natay major loss and minor loss. So natay due to friction, change in kuan of size, and then or direction, and others pa nga causes sa head loss. So ang ato na ding new nga Bernoulli equation, so we have here the P1 over gamma plus the Z1, which is this one, this is Z1, and then this is Z2, plus we have the V1 squared over 2G is equal to P2 over gamma plus Z2 plus V sub 2 squared over 2G plus the head loss. So nanay head loss, it is because due to friction. So nanay change of energy. Okay. So muna siya ang concept sa Bernoulli's equation nga ang energy 1 here should be equal to energy at this side. So if we rewrite the whole equation, ang ato ang total nga head loss, so ato ang total nga head loss, no? So our total head loss then becomes, kung ato ni ipang move dire, kay para head loss lang atong ma-solve, then we have the pressure 1 minus pressure 2 over gamma plus ang Z1, kay ato man move dire, i-transpose Z1 minus Z2 plus velocity head 1 minus velocity head 2. So we have V1 squared minus V2 squared over 2G. Or simply, we can write this as P over G plus Z plus V. So this will be our head loss.